Did you know that Europa, one of Jupiter's moons, has a subsurface ocean that might be twice the volume of all Earth's oceans combined? Europa, a moon of Jupiter, has long fascinated astronomers and astrobiologists alike. With its surface temperature of -160 degrees Celsius and its thick, icy crust, it's hard to imagine how life could thrive in such an unforgiving environment. And yet, this tiny moon is considered one of the most promising places to search for extraterrestrial life in our solar system. Exploring Europa is no easy feat, however. The moon's surface is a treacherous landscape of crevices and craters, making it difficult to design a lander that can survive the harsh conditions. And beneath the ice lies an ocean, thought to be up to 100 kilometers deep, which is almost impossible to access. Scientists would need a submersible capable of withstanding the crushing pressure and near-freezing temperatures of the European Ocean. One of the biggest challenges facing researchers is the lack of data. While several spacecraft have flown by Europa, none have landed on its surface or explored its ocean. This means that scientists are forced to rely on indirect methods to gather information, such as studying the moon's magnetic field or the composition of its icy crust. Despite these limitations, researchers have made some groundbreaking discoveries that suggest Europa's ocean may be more habitable than initially thought. The extreme environment on Europa makes it difficult to design a mission that can survive long enough to gather meaningful data. NASA's Clipper mission was launched in the mid-2020s. It did a flyby on Europa on October 2024, rather than landing on its surface. While this will provide valuable information, it's clear that more research is needed to fully understand the moon's potential for life. In recent years, scientists have made significant progress in understanding Europa's subsurface ocean. Data from past missions, such as the Hubble Space Telescope, has revealed that Europa's ocean is likely to be in contact with its rocky interior, which could provide the necessary energy and nutrients for life to thrive. Additionally, researchers have discovered evidence of water plumes erupting from Europa's surface, which could be indicative of geological activity and, potentially, life. One of the most compelling pieces of evidence for liquid water on Europa comes from the moon's magnetic field. As Europa orbits Jupiter, the planet's massive magnetic field causes Europa's ice crust to heat up, potentially creating pockets of liquid water beneath the surface. This process, known as tidal heating, could provide the necessary energy for life to exist. Further research has revealed the presence of organic molecules on Europa's surface, which are the building blocks of life. While these molecules can be created through abiotic processes, their presence on Europa suggests that the conditions for life may be more favorable than initially thought. Hydrothermal vents, similar to those found on Earth, could also provide a suitable environment for life to thrive. These vents would allow chemical energy to flow from the moon's interior into its ocean, providing a potential source of energy for microorganisms. The discovery of hydrothermal vents on Europa would be a major breakthrough in the search for extraterrestrial life. As we explore Europa, it becomes clear that this moon is more than just a frozen surface. With its vast subsurface ocean, the potential for life raises exciting questions about what forms that life could take. Imagine organisms adapted to survive beneath thick ice, thriving in dark, high-pressure conditions. What might these alien life forms look like, and how could they navigate Europa's diverse environments? The ice crust. First, Let's consider Europa's icy exterior. The surface is covered with a thick layer of ice, which can be up to several kilometers deep. This ice acts as a protective shield, insulating the ocean beneath. If life exists here, it would have to adapt to extreme cold and potentially low light conditions. One possibility is the existence of microbial life forms, similar to extremophiles found in Earth's most hostile environments, such as Antarctic ice or deep-sea hydrothermal vents. These microbes could be similar to tardigrades, tiny creatures known for their resilience to extreme temperatures and radiation. They might exist in a suspended state, waiting for favorable conditions to thrive. These microorganisms could be translucent or gelatinous, allowing them to absorb any available light from the weak sunlight that penetrates the ice. The subsurface ocean. Now let's dive deeper into the subsurface ocean. This ocean is believed to be in contact with Europa's rocky mantle, which could provide essential nutrients and energy sources. Here, life could take on more complex forms. Imagine bioluminescent organisms similar to deep-sea creatures on Earth, glowing in shades of blue and green. These organisms might have evolved to utilize chemosynthesis, deriving energy from chemical reactions rather than sunlight. They could form the basis of an entire ecosystem, thriving around hydrothermal vents that may exist on the ocean floor. These vents could create an environment rich in minerals and nutrients, enabling diverse life forms to flourish. Larger multicellular organisms could have evolved, resembling jellyfish or squid, utilizing jet propulsion to navigate the water. Their bodies might be adapted to withstand high pressures, with flexible structures allowing them to thrive in this dark, high-pressure environment. Ice plumes and surface life. Interestingly, evidence suggests that water plumes may erupt from Europa's surface, possibly carrying oceanic material into the space above. If these plumes exist, they could allow for the exchange of materials between the ocean and the surface, creating a unique environment for potential life. Life in these plumes could be quite different from life in the ocean. Here, organisms might be more exposed to radiation from Jupiter's magnetic field. These creatures could have thicker protective layers, or even develop shells or exoskeletons to shield themselves from harmful radiation. Some researchers speculate that if life exists in the plumes, it might take on more primitive forms, resembling microbial mats or biofilms. These life forms could be visible in the plumes, creating colorful displays as they mix with the icy particles and gases released into space. Variability in environments. The varied environments on Europa could also lead to different forms of life. For instance, in areas where the ice is thinner, sunlight might penetrate more deeply, allowing photosynthetic organisms to evolve. These organisms could resemble algae or phytoplankton, forming blooms in the upper layers of the ocean. In contrast, regions with hydrothermal activity may host life that thrives in complete darkness. Here, organisms would rely on the heat and chemicals released from the ocean floor, creating a vibrant ecosystem reminiscent of Earth's deep-sea hydrothermal vents. Moreover, If Europa experiences tectonic activity, it could create new habitats by exposing different geological features. This dynamic environment would provide multiple niches for life to evolve and adapt, leading to a rich tapestry of biodiversity. As we continue to explore Europa, we may uncover the secrets of its hidden ecosystems, revealing life forms that challenge our understanding of survival. The icy moon holds the promise of discovery, inviting us to ponder the possibilities of life beyond Earth.